Welcome to Math 105, Chapter 6.4, and we are working on just factorials, permutations, combinations. In another video, we're going to just kind of walk you through how to work through the marble problems using this sheet. I am open to any ideas and suggestions on making the marble sheet look a lot better. There's just so many variations that it's a little hard to figure out how convenient to make it and to make it look nice without giving too much away. Because again, this is for you guys to make look really nice. So first thing off, we talked about a factorial. So n factorial is the number of possible permutations of n items. So we had n factorial. It looks like the exclamation point, where a permutation is any sort of ordered list of those items. So for us, let's say our n is like this 5. So we can go ahead and put 5 here. And if we're doing 5 factorial, right, that's just saying 5 times 4 times 3 times 2 times 1. So instead of saying equals 5 times 4 times 3, right, and so forth, right, that gets a little tedious. So instead, we can type in the word fact, parentheses, and then we get to select our number. So instead of typing in the number 5, I want to be able to change it over and over again. So I'm going to just select a 3. So we have 5 factorial is 120, and you can see that over here on the other side. Now, again, if we wanted to do 7 factorial, notice that 5040 comes up. And we could do this as many times as we want. And you'll notice that it looks super small if you did 12 factorial, which we have 4.8 e plus 0.8. That just means that this cell is really small to contain this number because it is large. We should be taking this decimal point over here, and we're going to be moving it over 8 to the right. So if we expanded it to your cell, you can see it is a large number. That cell was just a little too small to contain it. So I'll probably snap it back here. And you could always orient your number in a way that you'd like. If you wanted to keep it to have three significant figures, 1, 2, 3, you can in scientific, or if you wanted just a number, again, sometimes when that number flashes up, it's just the cell is too small. I'm just going to snap it back to just a general non-specific. So that one is okay. Now let's talk about permutations. I need to expand that cell just a little bit. Permutations has the equation n factorial over n minus r factorial. So you could, in fact, do this as its own setup in the computer down here. But let's go ahead and just pick some numbers for r and n. So let's try this one. 6 is for your n, and p is to talk about permutations and ordered list. And then we have r being 2. So 6, select 2. And so we could, if we wanted to, say, okay, this is equal to, maybe I put it right here, equal to, okay, we want 6 factorial, actually, we want to do factorial, that number divided by, and then we want n minus r. So n minus r. Actually, this would want to be in a factorial. Sorry, keep forgetting we're not in a real calculator. So we want to do 6 minus 2, and then that factorial. And then again, you can see that here being 30. The double parentheses might not be necessary. I like putting on a couple extra just to be safe. So we could do that. And again, if you wanted to change it, you could do 12, 4, and again, still get your answer. However, what I want us to really do, so we want to use the permutation setting. So we can say equals permutation, permute. It says number. So this is going to be your n, the bigger of the two numbers. Of the pile, we're now going to be selecting a small minority. So that it says number chosen. That would be 4. And you'll notice that that should come up with the same exact answer as the one above. And again, If you wanted to do the same, it would be over here. Now I'm going to step that into this one. So both answers should be right. One is just using the formula, which we can certainly do. And this one is already using the built-in formula from Excel. Now let's talk about combinations. Permutations are ordered, whereas combinations are unordered. So n here, if we were to do the 6, 1, 6, and 2, it can be any sort of order. So order doesn't necessarily matter. So we could do the same thing. We could do the equation here. We have factorial of n divided by, and then it says r factorial. And I'm going to do an extra parentheses to start, r factorial times another factorial of n minus r. We close that one. We close the actual division. It looks like, oh, I did not put a multiplication symbol in between my two factorials because we are working with Excel and not a calculator. And there you go. So we should get 15. And again, we can change this one to maybe be 10 and 6 to show you that, again, we have that answer of 210. Or we could use the actual setting within your Excel sheets. Doing combin, and again, 10 being the larger of the two. This is n, the pile, and then what we are selecting within it. Again, 210 here. Again, you can do more or less. You could do the other one here. You could do lots of them, and I'll show you the difference. Let's say I stuck back with this 6 one, and if we did 10 and 6 here, notice that it's a much larger number because just one little alteration in an ordered list will create a whole new outcome. So notice that over here we have AGE, AEG, GAE, and GEA. Under a combination, all of those would be considered the same exact outcome because order doesn't matter. But under a permutation where order matters, these are different outcomes. You have 1, 2, 3, 4 possible outcomes just by reversing the first 3 letters or companies.